Hey everybody, happy Monday. It is the 1st of April. Some might call it April Fool's Day, 2024. What's happening?
Good morning.
Good morning. We get together at 1300 UTC on Mondays for an hour of talking about Cardano Go, and we call it Cardano Go Live Coding. We're building towards a PBL course. So the team over at Blink Labs is building a lot of open source repositories that are great for people to learn from, including some starter kits. And over at Gimbal Labs and on the Andamio team, we're building a platform to deliver some project-based documentation and onboarding materials for different sorts of devs to the ecosystem. And so we're just creating the raw materials for all of that now by bringing together some code examples and eventually some lessons. And last week, I brought to the table, so far we've created a couple islands where we can think about maybe writing data or querying the blockchain or building transactions. And then Chris, thank you for taking us on a pretty awesome journey showing why UTxO RPC is being built and how it's collaboration. I know we tweeted out about Blink Labs and TX Pipe, and you responded, it's actually there is more to it than that. So I want to make sure to give credit to everybody who is kicking in. Is there anybody we should shout out, or like if I update that blog post that we can add to it?
Wow. Yeah, Clark Alenza has been
Oh
doing
yeah.
the .NET stuff and has been working on that pretty well. And there's a few people that I cannot remember their names off the top of my head. But
Yeah.
yeah, yeah,
Matt Clark is on that. Okay, so yeah, I just want to update that blog post, and I'll make sure to drop into that Discord server and make sure
yeah.
that I'm getting credit.
The UTxO RPC channel on the TX Pipe Discord is where everybody hangs out. So,
Okay, on the TX Pipe Discord.
yep.
Cool, easy, good
Yep.
stuff. Thanks. So then, we have this idea where, and let's jump. So there's some links in the blog post, and one of them is to just the UTxO RPC project right here. We can look at the docs. We talked last week about there are these 4 different modules, which you can imagine in the long run, maybe there would be additional modules someday, governance, for example. But for now, like we have these guys right here, and we can do pretty much everything we need to do to build a Cardano application. And then what you guys shared, we put out a tweet, and then you shared that this guy was implemented over the weekend. So what's pretty exciting is that we know that these endpoints are coming online. Get chain tip, which is in the sync module, right? Is it down at the bottom?
No, that's in the build module. So the build
Oh, the
module
blog post
actually
is.
has, yeah, the build module has most of
Oh,
the
build module.
chain query uh, items because usually the local state query that you use is almost always for building a transaction. So that's why it's under the build module because it's all of the information you need to build, right? That module also has like, the UTXOs by address, other things like that we are going to be adding shortly. So like the parameters, right? The protocol parameters come out of the chain param response. I did the chain tip response because it was trivial to implement, so I'd have it ready for us.
Right.
But the UTXO by address, UTXO by ref is are pretty standard local state query stuff. The whole UTXO actually here is a little different because it's a kind of a new concept. But yeah, so we have implemented get
Is
chain
this
tip.
for like pending transactions and chaining, that kind of thing?
No, so it's for well, yes, you could do it absolutely that way. That's what you could use it for. Would be to prevent you from reusing them, right? while building a chain of transactions and things like that. So you could add to the list of UTXOs that you're building as you go. But the other way would be yeah, that would probably be the primary way I would see using hold UTXO.
Well, what did you have in mind? Yeah, it's interesting, like what you call this a new concept. So what brought this to
Right.
mind?
Right. So I'll be honest. I'm trying to figure out what the real use cases for it would be. I think there might be a better explanation for it under the intro for the build module
Yeah.
rather than
Hold
the spec. Right.
variables, hold UTXOs for
Right.
build. Yeah. Okay.
Right. So it's as you said. I mean, it would preventing them from being spent, so that you don't use them
Right.
in generating transactions and that sort of stuff. So, that's exactly as you said what it's for. And, updates about lost UTXOs would be things that don't actually make it right to chain, that sort of thing.
Right.
So, as you said, chaining transactions would be the primary reason I could see for doing it.
Very interesting. I mean, to see that, yeah, like natively here as a first class citizen across alongside the other ones is pretty neat. And I need to learn a little bit more to understand exactly how you would manage that. So if we have this endpoint, right, that's bringing in, we're able to somehow manage that list, but we also want to be able to, yeah, update that list in a regular way. All right, well, that's something to explore in the future.
Right.
So one by one, these things are being implemented, and I was thinking today we could just troubleshoot. I did set up my Demeter RPC port here.
Ah,
Um, and I just didn't quite have time to just make sure this function was working as it was kind of published in the examples repo. So I was wondering if we could like troubleshoot just one thing there.
sure.
And then more generally, right, what that then leads to is I used the term right before we started recording, like all of these endpoints allow us to think in terms of pseudocode, but you said it's one step better than that, right?
Right.
We can, if we write code using these methods, it's
It's
code
the
that
actual
will
code.
work. It's the actual code that will work in
Right.
applications as each of these, as the spec is implemented in any given language.
Correct. Correct. Yeah, the pseudocode will not be pseudocode because you already know what the shape of every response is, you know what the shape of every request is, you know what the individual services are, you know what their names are, you know what their function names are, all of these things already because it's built from the spec. So you even know that the function name is the same, on Dolos built via Rust and on Cardano Node API, being built in Go because we're building from the exact same spec.
And that's what allows us. So here, jumping over here, that's what allows us to say, hey, look, this the actual provider of our data is actually sourced from Dolos running, which was written in Rust, but that's fine, doesn't matter to us. We're able then to use what you're implementing in Go here natively, for example, with this chain tip function. My problem is you can see what my problem is, right? I just all I did is copied and paste. I didn't have time to troubleshoot yet. So I brought in
Yeah,
the
the
URL.
main issue with this guy, and this is the main issue that you'll run into with gRPC in general, is the versions have to match exactly on both sides. And
Okay.
currently, while we are in V0 and our V1 Alpha 1 versioning, everything below 1.0 we consider to be, us still completely testing. Um, so I would need to validate exactly which version of the UTxO RPC you have there. And then
Ah,
we would need to make sure that we're using the right version of the code gen for that. So currently, yeah, let's take a look at what we have. Yeah, so you're using 044. I bet you it's probably, I mean, and that's the current version. Demeter is probably still on 040.
Oh, okay.
All of the 1, 2, 3, and 4 releases were me trying to get the code gen publishing pipeline to work transparently. So there were no actual code changes to anything other than the pipeline,
Mhm.
but it still produces different versions, right, of the gRPC. So, when it does the version check, it's like, hey, we don't match.
So if I tried 0.40, maybe this guy works.
Yeah, let's find out.
See what happens. So how do
Yeah.
I change that version here? What do I do to update? Oh, looks like this guy needs a different.
Yeah, it's complaining.
So what do if I just tidy this, will it do it for me?
Yes, go for
Some
it.
some of that
Go ahead.
still feels like magic to me. So I know that
Yeah, that's right.
oh, hi there.
Today. Nice. All right, what did it come up with?
All right, looks happy enough.
Did you build it again?
I did, or well, let me try. Is there anything like cached that anything else I would have to do because
No, no. And as I'm telling you, unfortunately, I don't know the exact version that's running on the other
okay,
side.
yeah, yeah, yeah.
So
How so
it-
should we
it's-
go? Can we figure that out? Uh,
when did you create this? Just recently?
yeah, just like a few minutes ago.
Give me just a moment. Let me find out. Let me see if I can find out. So while I'm actually taking a look at this, do you want to maybe continue on? And if you give me just a minute, I can actually set up a version of that Cardano node API right now
Okay.
and make it available. If you give me just a moment.
Yeah. Well, does anybody else have any questions or thoughts about anything we've done so far? Whether it's the concept of playing with UTxO RPC or anything in Go? I can jump over here. I was looking at the Demeter docs just to see if we could find anything about what version this was, but more generally, for people who don't know, Demeter Run, and just the website is demeter.run. Oops. Is a provider of Cardano infrastructure. So you can see right here, you can come, you can make an account. I'm signed in with my account. And when you do log in, you have your set of projects. I still have a placeholder project that I was using last year at Gimbal Labs for Plutus PBL. So for now, I was still just using that one. And you'll see that right now I only have one resource running, and it's that UTxO RPC port. And this is exactly what gives me the URL that I'm pulling in right here and using just to play around with in this file, right? And if this was a bigger application, obviously I wouldn't have this just once in this file, but we're just playing around building little toys to kind of get a feel for things. But what's really cool about Demeter, if I click on add resource, is you can see there's a whole bunch of other services exposed here. I'm not going to go through and read each one, but for example, right? Hey, you need a Cardano node so you can, for example, learn how to use Cardano CLI. This is one thing we're going to show people in the new version of the Plutus PBL course. You don't have to have it running locally and sync it yourself. you can use this as a service. And you know, there's a certain amount of free credits, but if you need to, you can pay for access. And you can see there's all these other services as well. Some pretty exciting stuff. Anybody have any questions about this, or maybe success stories about how you've used Demeter in development? Yeah, any one of these would be fun to jump in and play around with.
Yeah, so there is the workspace, right? So in the workspace, you get a VS Code environment. And there are the Demeter starter kits you can use that will launch workspaces.
Oh, cool.
Right.
Yeah.
That's what the Demeter starter kits usually are, as a workspace.
Right. So this gives, so anybody can create a starter kit that allows people to come in and have VS Code in their browser.
Exactly.
Do that.
Exactly.
And you've got all these. So what I just clicked on workspace, top
Mhm.
first option. Yeah. And now I get a whole bunch of different choices. Okay, what am I developing in?
Oh, well, you're developing in Golang, right? Good for
For
creating
today,
projects
there you
in
go.
Ouroboros, yeah, right?
This looks good to me.
Yeah, yeah. And like, if depending on what you might need a Cardano node, right?
Right, right,
And that sort of stuff. So if you were to, for example, be launching the Ouroboros starter kit, you would want a Cardano node. You don't need the CLI binaries, but down below you'll see you get to choose what network do you want to be on.
right. Okay.
Right.
And a preview for now is where the RPC, well, Demeter RPC is, but
Yes,
I
yes,
could
that's right.
really use, yeah.
Right, right.
Oops.
All right. So
Right. Right. And I can copy if somebody else built a starter kit already. There you go. Just make a copy of that and pull those settings in.
okay. All right. So I just found the version of UTxO RPC that's still in use in Dolos. And even the latest version that was released 2 days ago is still on version 0.30, which we do not have a Go code gen of at all.
There you go. Okay. Okay.
So if you give me a little bit, you can continue on. I can get UTxO RPC, the Cardano node API, up and running for us, but it's going to take me a few
Cool.
to get.
Well, so yeah, so the rest of us can sit, thanks, Chris. We can sit and think about now, look, this is what we're going to have, right? So now
Yeah.
make
Now to start with,
notice,
I only have tip, right? But
right, right, for now, right? But we can start thinking ahead to this and we can start comparing it. Like I, one of my forward going questions is, okay, given UTxO RPC is being rolled out, but also given that when we jumped into this work, we recognized there is this ecosystem of other development libraries. I I want to understand like what are the cases where somebody would want to use those libraries instead of UTxO RPC and be able to decide on that. Um, but certainly we can start playing around with some case studies and see how far we could take this thing. So for example, Mix showed us how to build a simple transaction, but how would I do that here, right? I can get UTXOs by address. That's part of building a transaction. That's pretty cool. Sheesh. Envelope that holds a UTXO from any compatible chain. It's forward looking.
Indeed. And if you look at chain param, for example, here, you take a list of them when you do the chain param, like you see the label can be repeated.
Mhm,
The list of parameters when you actually go the chain param request.
mhm, mhm. Right,
Right.
right,
So you can
right,
see, you can have which parameters do you want. So when you're building a transaction, right, like what things do you need to know out of the protocol parameters to be able to build your transaction, right? Your costs, etc. Min fees, right? Like all of that sort of stuff, that is necessary to build a transaction. This is where you get it from. The interesting thing is you can ask for exactly the parameters that you need and
right,
only the
right,
parameters that you need,
right,
and you'll get those parameters back in your response. So it is the bare minimum essentially necessary to build a transaction, right? So like UTxO ref, you do UTxO by address, and you'll do that on, for example, your wallet,
right,
right? Maybe the UTxO by ref is, the script or whatever that you are explicitly going to be interfacing with, and you don't need its whole wallet, right? Like you
right. I need to
so
know the UTXO. Right. This is the validator UTXO I'm trying to spend. This is
reference
the
inputs
reference script.
generally, yeah, would be
Right.
this. I mean, like obviously you could use it if you already know what UTXOs you want to use, you got them from somewhere else or something like that, right?
Okay, so that's a question, right? So I've got a bunch of UTXOs at a validator. I want the one that has this token in it. So how
To do
that's
that, you
that's a
would pull it by
query.
address.
I would query by address, and then I would filter those results for my token. Right. Yeah.
Right, right. But like again, kind of going back to the UTXO ref, where you might even use this in building a transaction yourself, would be if I mean, out of your own wallet or something like that, would be if you're interfacing with some other piece of code, right? Like maybe your front end over SIP30 talks to the wallet and gets a list of UTXOs from the wallet and passes those through to your backend. And now you already know the UTXOs you want to look up to generate a transaction, right? That you might be passing back to the front end to sign.
Right. Right.
So, if you're doing that sort of thing where you're building a transaction on the back end, you might only get a list of UTXOs instead of needing to scan their entire wallet, right? And the advantage there would be, like they're an NFT degen, they've got like 100,000 UTXOs in their wallet, right? Terribly fragmented or
Right.
whatever. They
Right. Right. Right.
UTXOs potentially blocked or on hold. Like we have the ability to hold UTXOs, but wallets kind of do too, right? You can lock a UTXO in Eternal, for example, and it won't return them as a UTXO
Right.
usable as long as you query the wallet for them.
Right.
So this is a case where there have been problems already that people have seen in the ecosystem where if you build a transaction on the back end, right,
Mhm.
they don't necessarily know that because
That
that
these UTXOs are held.
right, that these UTXOs are locked or held or anything like that. So like now you also kind of like have a way where that could be communicated to a
Right
back.
on. Right. 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 Yeah. This holding state helps me inside of my application's logic, but it doesn't necessarily mean anything to the outside world. What if it could?
Right.
That's interesting. And yeah, we have some cases where once we do find the UTXO, we're actually not interested in spending it, but we do just want to reference the datum. So this could be the case there. Okay, yeah, I have this. It's it's referenced in our validation logic. Um, yeah, but so if I want to read the data, where's the UTXO? Right, TX output, UTxO RPC. Yeah, this, I want to look at this type. Um, this is where we can find a lot of the types used throughout the spec. And message is a keyword in Proto. Syntax Proto 3.
So this is actually looking at this in the from a Go standpoint. This is easier to read out of the Go code gen.
Yeah, well, these are structs, right? In that you'll see in Go.
Correct. Yeah. So these are the
And
definitions
message.
of
Why did you choose the word message?
because this isn't Go.
All
This
right.
is
All right.
protobuf, and we're describing essentially a packet of data, and their
TypeScript
definition for that
again.
is a message.
So TypeScript takes a message from Proto and says, okay, here's the type. Go takes a message and says, here's the struct.
Yes, exactly.
And then we can look at those. You said in the code gen, but that's in this repo still.
No, the Go code gen is a separate
That's
repo.
right, it is different. Same five, right. So there's the 4 directories, sorry, what's my modules? Okay.
Yes, the 4 modules, and then the Cardano module, which is essentially all of the main types.
Yeah.
Right. So this will be all of those that you saw, the messages, right?
Right.
Those proto messages are now here. And you can even see the source, right? UTxO RPC, V1 alpha, Cardano, Cardano.proto.
Yeah. Okay. Good.
And you can see like, so how to get a string representation. If you keep going down, you'll see the actual various things like a TX output and that sort of stuff. You can.
Gosh. Now, right on. Perfect. Yep. And that's everything we would expect here.
Right, right. And you can
Along
see
with
even
this.
you can see differences even in the types that kind of show up, right? So here, if you look at coin, for example, and we have a uint64 in Go, right? And we say, oh, it's actually a varint in protobuf, right? You see what I'm saying? So it's like all of that kind of information is codified in here so that it's able to go back and forth between the two. So we're now we're saying, oh, okay, this is the protobuf configuration. So Go's protobuf compiler knows what to do to convert this struct back
And
into.
but this was a decision.
That's made by the protobuf compiler.
Okay. Made by the protobuf compiler.
So if you see, we used proto C gen Go.
Yeah.
Version 1.33. That's the version of the proto buff compiler for Go that was used to build from our source to generate this.
The spec is written, it's that .proto file, and then we have a compiler to Go. He used this one, and that's where all this comes from.
Exactly.
Right.
That's what generated this.
Right. And it says, okay, to match this spec input or output, we're going to represent this as a uint64, for example.
Yep. And if you scroll down, you should see the full breadth of, like what a TX output looks like, what things are allowed to happen, right? So you can see coin, returns the TX outputs coin, get address, right? So like all of the functions that are, these are the functions that you see in the docs, right?
Exactly. Okay, so this is now still an awful lot. This does take us an awful long way. Where is the first thing that you or anybody else who's actually implementing this now? Where do we go to implement this? All right, I'm ready to implement get coin, for example. That's
So this is where I have started some of this, and I have been putting it all into Goroboros.
okay. And
So
so so
I'll
it
show you where it
event
is.
yeah, it eventually ends up in Cardano Node API, but before you
Correct.
go there, you're building into Goroboros.
I am so there are two parts. The individual changes that are made to the objects, that sort of stuff, I'm putting into Goroboros, so I can show you that. But when it comes to implementing the handlers and functions for actually using these things,
Mhm.
right? That will go into Cardano Node API. So
Right.
if you take a look down here at our buddy, yeah, Goroboros, and we can just look at the ledger, and like I'll show you. We'll pick something. So like let's just pick Babbage, just for simplicity's sake, and scroll down a little bit, and you'll find a UTxO RPC. In fact, look, you can already see we have UTxO RPC in our imports,
Right. Right.
right? Because we are going to be implementing, some of it. So if you scroll down here just a little bit, you don't even have to go too far, because I'll show you in just a moment. We have a UTxO
Uh,
RPC function. So this produces a block.
right.
So, and you'll see we have a Babbage transaction body here too, right? So if you have a Babbage transaction body or whatever from Goroboros, you can now call .utxo RPC on it, and you will get a UTxO RPC representation of that same object, right? So we're building the conversion
Right.
between essentially, like, not necessarily CBOR. We're building it between the Go and UTxO RPC. So we're adding all of the things. So you'll see on a body or whatever, we might have an unmarshal CBOR, uh, or a marshal CBOR to go to and from CBOR if necessary. Yep, like this guy right here.
Right.
Which is, how do we take this and convert it, back into bytes, right?
Right.
CBOR.
Right.
So we're building the same things for UTxO RPC, so that we'll be able to go back and forth. Um, you
Damn.
know,
Okay.
and yeah. So we're putting those in at the primitive level in Goroboros, but then like an implementation actually using those things will be in UTxO RPC.
All right, let me see how accurate I can be. So I can any node, right? Goroboros has several different ways to connect to a node running anywhere, whether it's locally or elsewhere.
Right.
And now it's Goroboros is already built to allow me to kind of talk natively to the node. And that opens up all sorts of opportunities. And at the very same time, ultimately, what I probably want to do with that data is use it with these really convenient UTXO RPC functions.
Right.
And Goroboros is already putting data in that format for me. It
Right.
says, all right,
Well,
yeah,
you can easily convert all of the native Go functions, structs, right,
right.
into either, right. So you can either convert it into a CBOR encoded byte array,
Yeah,
right, which
yeah,
is, with the CBOR marshaling,
yeah.
or you can convert it to UTXO RPC
Right.
right here. So one of the things we'll probably end up putting somewhere along the way, we don't have it quite yet, is the opposite direction, and create all of the UTXO RPC to Goroboros struct, right? The opposite direction, so that you can take data in from UTXO RPC in any way and then convert it for passing back out. But for the most part, we're able to do it, anyway, because we're
Right.
it's going one
That'll
direction.
gradually add flexibility, maybe, right? Like,
Right. Well, I mean, if we were wanting to build something more like Dolos and build a standalone node,
right.
right? that does not use a Cardano node for its data source, that used its own data source, then we would have to be able to convert those things back and forth. In this case, we're using a node for data. So we know everything that we're getting essentially as input is coming in as Ouroboros as Cibor, right?
Mhm,
Because that's what the node provides.
mhm,
So we're building the one way,
mhm,
right, of taking Cardano's ledger state, which is binary Cibor, and converting it into UTxO RPC. At some
mhm.
point, we will need to go the other way because UTxO RPC could be the way that we're sourcing data to,
Right.
right? And when we start building out that functionality, we'll have to build the everything out to go the other way too.
Excellent. Okay. Okay. No, this makes more sense each time. Thank you. And yeah, it's wild. It's very exciting to see this just built in to Ouroboros. Okay, and I'm gonna be excited to take that on like a few full laps, and we can kind of play around with giving people ways to kind of really appreciate that flow of data. That's really cool. Okay. So I've been tooling around and bringing all these questions now. Um, do you think we can beat the clock getting the code gen to work over here?
I am typing fast. Yeah, you like my quick cheats here.
Oh,
So
it's so helpful to see it in this state, right? So like this is the one we can now play with. There's the implementation. There's the use
right.
of Goroboros.
And then you can see where we build the chain point here to be the state that is wanted
Yeah.
by the build module, right?
Yeah. Yes. Yeah.
And so what's kind of interesting to look at here is the tip that we get from Goroboros is shaped a little differently than the chain point. For Goroboros, a point only has a slot and a hash
Right.
because it's an absolute slot. So it doesn't include the block number. But I mean the entire tip does, but the point itself doesn't.
Right.
Uh,
Right.
whereas we have the point in UTxO RPC does include the block number.
Because we might want that.
Because we might want that. Right, right.
Right.
It's useful for other reasons when, like building transactions, doing things like that, right? So,
Right.
so it was just additional data that was added directly into the point, instead of it being like specifically a tip response, right?
Right.
So
Right. And where and this, so when I say, what do we say? Get chain. This is the chain point. Got it. Right. So, right. I can look in these docs. Here it says that's a chain point. What's a chain point? Well, for example, we were just looking, where was I just? No, here. It's this chain point. Obviously, that's defined upstream, but there's an example of it in the implementation. It doesn't seem out of the question that we can bring contributors in to help and implement some of these. If we have a few examples and the work is in progress.
yeah, I will be this is actually our catalyst work
Okay,
for
fair.
for Fund 11. So I will be definitely completing these and
Okay,
doing them as my proof of achievements and milestones and all of that sort of stuff. We're actually about a month ahead here on where I'm supposed to be on Catalyst, which is why I didn't have any of this stuff implemented, and also why I didn't want to go too far ahead, because then I'm kind of working on things a little too out of order,
yep.
and I get in enough trouble for that one. So
That's good. All right, awesome. Okay, but
so here's what I'll do
so
is
right.
we should reach out. I'm going to reach out to TX Pipe and we'll make sure that we get updated to the latest version of UTxO RPC over there, to version 044, and that way it'll be on their service as 044.
Awesome. Cool. And then I can even make a little like companion 90-second video just showing that working. So we have it. Uh, throw that into this week's report post. Um, but yeah, and then it feels I feel confident enough with my ability to like watch what's happening here and see how these pieces get together that now we can move forward with these live coding sessions. Just starting to play with these as they come online. And then we can play around with what we're able to do with them, take them as far as we can. That's
Yeah, absolutely. And also, I have my entire team here is on the call, so no one was paying attention to my pull requests. So we'll have everything deployed out. So we will. I'll make sure that I have a Cardano node API that's public, that is deployed out, that has these things available, so that we can go and play with them. right? And as I build them and update them, I will make sure that those versions get updated, on the public version so that, it keeps up.
Fantastic. Happy Monday. There you go. Sounds
Happy
like we're
Monday.
good to go.
Yeah, yeah. We were going to show off a bunch of code working. April Fools.
This is perfect. This is the perfect spot to be. We're underway. This is our fourth session here. I feel like we've done a really good job so far, just kind of framing how we can work, what that can look like. Yeah, so all systems go, and 1 week at a time there. My, I still feel like I have a little bit of an unresolved question as to like, okay, given UTxO RPC, when do I use another library natively? And I kind of just want to like keep coming to that question on every couple of weeks and saying, okay, well, here's as far as we can go. Is there anything, is there a reason to pull in a library, to do
Right,
this or that?
right. So, I mean, the two ways and the two easiest points to answer this, really quickly in the last couple of minutes that we have is it would depend on what you're trying to build. Being is that how we're, doing the Go PBL here, right? The place where you would want to add easiest the UTxO RPC support would be adding something like Apollo,
Mhm.
right, as a back end to Apollo, as an alternative to Block Frost or right, or Maestro or any of the other API providers would be selecting UTxO RPC there. And then, it's just a choice of whose UTxO RPC you're using, right?
Right.
You know, this is again, we're kind of in a state of flux, and as you saw, the
Yeah.
TX pipe is in 030, 040 is current. So like, we got to make sure that we're all on the same page. The point being is when we stabilize, which should happen sooner rather than later, because again, all of this code, the UTxO RPC code itself
Mhm.
is, generated, right? We have a spec and we generate the code. So the point is we're just trying to bug shoot, troubleshoot and bug fix the spec itself. And
Mhm.
once we have that into a solid state, by getting more developers playing around with it, we're going to solidify it. It's going to be a V1 and there will be no changes to it whatsoever.
Right.
So
Right.
everyone's V1 will be identical to each other,
That makes
right?
sense.
And we'll know it's compatible. And if we break compatibility, it's got to be a V2.
Right. Right.
Right. Like that's the answer, is it'll have to be that way. And that's what we're all agreeing to, like as the UTxO RPC community, right? Is that we want strong guarantees, we want hard contracts, our API endpoints are hard versioned, right? And the goal will be we get to, V1 and it's compatible across the board, and new features go to like, breaking compatibility stuff goes to like V2. Right.
That makes so much sense. Yep. Yep. Brilliant. And then
Um,
with
so,
the Apollo stuff, so then that also makes sense. Like now you're talking about UTxO RPC as the provider to Apollo, which then
right.
the next more interesting question for me is like, okay, what's the value add of Apollo on top of that, right? Like now let's look closely at what that provides, what it allows us to play around with. And
Right. And other examples of libraries that you might use instead would be like Lucid or Translucent, or, one of
exactly,
these is
exactly,
you do the same thing. You add a UTxO RPC back into it, and
right,
now it works on everybody's UTxO RPC, right?
right.
So
And,
that's
and
the
yeah,
idea.
TypeScript devs will be clamoring for this, right? Like
Right.
once it's out there, it's like, oh, why don't we have that yet? Let's go.
Right.
It's
Right.
great.
And yeah, that's really the goal, is the interoperability. We want people to be able to take their app to different providers that are providing different things, or to self-host or anything like that, and it always looks the same.
Right. Or to be able to write a code base that uses a little bit of this and a little bit of that, right?
Yeah,
It's
absolutely.
you can write an API in Go and you can write a front end in TypeScript and you can talk to each other about it because
Very common. Yeah, very
right,
common, right?
right. Very cool. Very good. Thanks. I feel great about this session because I think this is like foundational stuff that's really helpful for those of us here just to know in the background. And as we start to branch out, as we start to, for example, start writing public facing lessons, this is not stuff you're going to tell people in the first few lessons, but it's good for us to have it in the back of our minds. Like we're guiding people towards this point where they can start to use this. And if anybody asks, to be able to show them a little bit about what's going on under the hood.
Absolutely. And the fun part here is we are absolutely, doing project-based learning. It just happens to be that we're building the server side
Yeah,
too as we go along, right?
This is not some BS project. This is not contrived.
Right, right.
This is actually it's actually a project. Let's learn from it. Love it. All right, team. Thanks again for the inspiring start to the week, y'all, and for hanging out. And Chris, as always, really appreciate your guidance on this. Thanks. Till next time, have a good week, everybody. See you soon.
Bye.
Bye.
Bye.